In this lecture, I am going to discuss some more problems on tangent plane and normal line. So we'll move to the problem. The surface cylinder f of x comma y comma z is equal to x square plus y square minus 2 is equal to 0, and a plane g is equal to x plus z minus 4 is equal to 0. So meets in an ellipse. So find the parametric equation for the tangent line to ellipse at the point 1, 1, 3. To the solution, so just to draw the cylinder in the xyz space coordinate geometry. So this cylinder which I have drawn, so that is x square plus y square minus 2 is equal to 0, and inside the plane x plus z minus 4 is equal to 0. It will form a ellipse here. So this is the ellipse here. So when inside the plane will form the ellipse on the cylinder. So then gradient of f, just fix the point on the ellipse. So the point is 1 comma 1 comma 3 here. So in this point just to take the gradient of f. Gradient of f can be defined by, so gradient of f is equal to dou f by dou x I cap plus dou f by dou y into j cap plus dou f by dou z into k cap. So dou f by dou x, dou f by dou y, and dou f by dou z can be calculated by the cylinder x square plus y square minus 2 is equal to 0. So gradient of g can be obtained from the equation of plane. So gradient of g and gradient of f are the perpendicular. So easily you can find out the tangent line at the point 1, 1 comma 3. So on the ellipse here. So this is the tangent line can be calculated by cross product of gradient of f and gradient of g. So all the three vectors are perpendicular here. So we gradient of f plus cross gradient of g is parallel to the tangent to the point p naught at 1, 1, 3 to the curve ellipse. So from the figure we observe that the tangent line is perpendicular to gradient of f and gradient of g at the point p naught, where p naught is equal to 1 comma 1 comma 3. So therefore the tangent line is parallel to, so that is v, let us call that is equal to gradient of f cross gradient of g, where gradient of f and gradient of g are the vector. So where gradient of f is equal to dou f by dou x into I cap plus dou f by dou v into j cap plus dou f by dou z into k cap at the point p naught. So where dou f by dou x is differentiate the function f with respect to x, we get 2x into I cap. Dou f by dou y is that is 2y into j cap. Dou f by dou z is 0 into k cap. At the point 1 comma 1 comma 3, so therefore gradient of f is equal to 2 into I cap plus 2 into j cap plus 0 into k cap. Similarly, let us find out the gradient of g, where gradient of g is equal to, so dou g by dou x into I cap plus dou g by dou y into j cap plus dou g by dou z into k cap, where g is equal to here x plus z minus 4. So therefore gradient of g is equal to, where dou g by dou x is 1 into I cap plus 0 into j cap plus 1 into k cap. At the point 1 1 comma 1 1 comma 3 also, gradient of g is a constant vector, therefore 1 into I cap plus 0 into j cap into 1 into k cap. So let us find out the v, where v is equal to gradient of f cross gradient of g. So that can be written as, in the first row I j k, let us write. So gradient of f, components 2, here 2 and 0, and gradient of g components 1, 0 and 1. So let us find out the determinant of this. I cap into 2 into 1, 2 minus 0, minus j cap into 2 into 1, 2 minus 0, plus k cap into, so then 2 into 0, 0 minus 2. So this is equal to 2 into I cap minus 2 into j cap plus minus 2 into k cap. So this is a vector v. Okay. So therefore the tangent line is, x is equal to x naught plus v1 into t, where v1 is equal to 2, v2, v1, v2 and v3. Components of v can be represented by v1, v2 and v3. And y is equal to y naught plus v2 into t, and z is equal to z naught plus v3 into t. So this implies x is equal to, x naught is 1, v1 is 2, 2 into t, y is equal to, where y naught is 1 plus v2 is minus 2 into t, z is equal to, where z naught is 3, and v3 is equal to minus 2 into t. So this is the equation for the tangent line at the point p naught is equal to 1 comma 1 comma 3. So we'll move to next problem. Find the parametric equation for the tangent line, so to the curve of intersection of surface x square plus 2y plus 2z is equal to 4 and the plane y is equal to 1 at the point 1 1 comma 2. So let us move to the solution. So you can observe that the tangent line will form when the intersection of surface and the plane here. So there we can draw the tangent at the point p naught, where p naught is equal to 1 1 come off here. So the tangent line is perpendicular to gradient of f and gradient of g. Gradient of f can be obtained by the function x square plus 2y plus 2z is equal to 4, and the gradient of g can be obtained from the plane y is equal to 1. Let the given function f of x comma y comma z is equal to x square plus 2y plus 2z minus 4, and g is equal to y minus 1. So let us find out the gradient of f, where gradient of f can be written as dou f by dou x I cap plus dou f by dou y into j cap plus dou f by dou z into k cap. So this implies this is equal to gradient of f, where dou f by dou x, just differentiate function f with respect to x partially with respect to x, treating y and z are constant, x square differentiation 2x I cap. So when you differentiate partial with respect to y, so we'll have a 2 into j cap plus difference with respect to z, we get dou f by dou z, so that is 2 into k cap. So at the point p naught, that is equal to 1 comma 1 comma 1 by 2. So gradient of f is equal to 2 into 1, 2 I cap plus 2j plus 2 into k cap. So similarly, let us find out the gradient of g, where gradient of g is equal to gx into I cap plus gy into j cap, gz into k cap. So differentiate g with respect to x. So there is no x here. This will be gx will be 0, 0 I cap plus differentiate with respect to y difference in 1 plus 0 into k. So there is no z term here. It becomes 0. So therefore gradient of g is equal to 0 I plus 1 into j plus 0 into k. So let us take where v is equal to gradient of f cross gradient of g. Gradient of f cross gradient of g, which is perpendicular to the gradient of f and gradient of g. Therefore tangent line is parallel to the gradient of f cross gradient of g. So this can be written as I j k. Gradient of f components here 2, 2 and 2. Gradient of g component 0, 1 and 0. So this is equal to determinant of 3 by 3 matrix here. I cap into 2 into 0, 0 minus 2 minus j into 2 into 0, 0, then minus 0 into 2, 0, that is 0, plus k into 2 into 1, 2 minus 0. So that is minus 2i plus 0 j cap plus 2 into k cap. So take it as v1, v2 and v3. So therefore the equation of tangent line to the intersection of two surfaces given by x equal to x naught plus v1 into t, y is equal to y naught plus v2 into t, z is equal to z naught plus v3 into t. X is equal to where x naught is 1, x naught is 1, y naught is 1 and z naught is off. So therefore x is equal to x naught is 1, where v1 is minus 2, into t, y is equal to y naught is 1, v2 is 0 plus 0 into t, and z is equal to z naught is off, v3 is 2, 2 into t. So this is the equation of a tangent line at the point 1 comma 1 comma off to the curve. So we'll consider another problem. Find the parametric equation for the tangent line to the curve of intersection of the surface x plus y square plus 2z is equal to 4 and the plane x equal to 1 at the point 1 comma 1 comma 1. So that is p naught. Let us move to the solution. It is like similar to the previous problem. The tangent line is perpendicular to gradient of f and gradient of g, where gradient of f and gradient of g can be obtained by the surface x plus y square plus 2z is equal to 4 and x equal to 1 respectively, where gradient of f can be written as dou f by dou x into I cap plus dou f by dou y into j cap plus dou f by dou z into k cap. Similarly, gradient of g is equal to dou g by dou x into I cap plus dou g by dou y into j cap plus dou g by dou z into k cap. So let f is equal to x plus y square plus 2z minus 4 and g is equal to x minus 1. So let us find out dou f by dou x. So that is equal to 1. So dou f by dou y is equal to 2y. Dou f by dou z is equal to 2. At the point fx at the point 1 1 1. So where that is equal to 1. So fy is equal to 2 where y is 1. Fz is equal to 2. So dou g by dou x is equal to 1. Dou g by dou y is equal to 0 and dou g by dou z is equal to 0. So let us substitute in the gradient of f. Therefore gradient of f is equal to dou f by dou x is 1 at the point p naught, 1I plus 2j plus 2 into k. Similarly, gradient of g is equal to 1I plus 0 into j cap, 0 into k cap. So let us find out the v, where v is equal to gradient of f cross gradient of g. So where v is parallel to the gradient of f cross gradient of g, that can be obtained by ijk, where gradient of f is 1 2 2 and gradient of g is 1 0 0. So this is equal to I cap into 2 into 0 0 minus 0 into 2 0 minus j cap into 1 into 0 0 minus 1 into 2 minus 2 plus k cap into, so 1 into 0 0 minus 1 into 2, that is 2. So 0 into I cap plus 2 into j cap minus 2 into k cap. So where v1 is 0, v2 is 2 and v3 is minus 3. So therefore the equation of tangent line is x is equal to x naught plus v1 into t, y is equal to y naught plus v2 into t, z is equal to z naught plus v3 into t, where x naught is 1, where v1 is 0, 0 into t, y is equal to 1 plus where v2 is 2, 2t, z is equal to 1 plus v3 is minus 2 into t. So this implies x is equal to 1, y is equal to 1 plus 2t and z is equal to 1 minus 2t. So this is the equation of tangent line, where